This is project 2 video number 3, the one in which we coded up. And I'm going to go to the editor, and we're going to create a function. It's not returning anything, so I'll name the return variable dummy. It's just a placeholder, and making some graphs of position versus time. I think I'll call it PVT for position versus time. And it takes no arguments, so I got nothing inside the parentheses. I'll put an end statement for the function, tab over for the body of my function. Alright, let's go to my the pencil and paper part. I said I need to initialize the variables, so go baseball, V0, etc. Let's see if I can remember any of those. So Y0, the initial height of the baseball, is equal to 0.15 meters. I'm guessing it was a centimeter. I don't want that printed out, so I'll put a semicolon at the end of it. R0 equals Y0, same thing. That is the distance that the positively charged particle is away from the negatively charged particle initially. And V0 in both cases is equal to 25 meters per second. K equals 8.99 times 10 to the 9th Newton meter squared per coulomb squared. What else do we have in there? Let's take a look. Q and QF. So Q 567 times 10 to the minus 9th, and we got a mass 0.25. Let me see that again. 0.25 grams. So mass equals 0.25 times 10 to the minus 3, e minus 3. I wanted to put charge in there. Q equals 567 times 10 to the minus 9. And Q F, the fixed charge, equals minus, and I forget what that was, minus 2.3098. Times 10 to the minus 6. So minus a negative 2.3098 microcoulombs. And then what else do we have there? Y max is 32.038. And that's meters, and R max equals Y max. Then what else do we have to do? What do we have to do next? Create an array of R values from 0.5 meters to R max and back. So I'm going to make this a function of n, and then we'll find out what a good value of n is, and just say n is equal to that somewhere in the code. So for now, as I test this, I'm going to be the user, and I'm going to put in how many points I want to work with. It's nice to have it small for if I need to print stuff out, so I don't have too many numbers printed out, but then large so that it works very well. Alright, this is going to be an array. Let me I want to show you some stuff with arrays. This is our command level, so this is our playground. I can create an array of values. A, for instance, I'll go 0, 10, 20, 30, and there it is. It tells me A contains this set of numbers in that order. And another way of creating that same array, which is useful when you start to get to the point where you got a lot of elements, is a built-in MATLAB function called linspace. So B equals linspace, and linspace is good for filling up an array with a bunch of equally spaced values. So linspace, it seems like it should be constant space, but so I want to go from, I want to create the same array but using this automatic method, 0, 30, and I want, I think what I put in here is how many values I want. I want 4 values total. So 1, 2, 3, 4. Notice if I went just 0 to 3, I would need 3 plus 1 values, the 4 values, similarly here. So let's see if I got that right. Yeah, linspace is a good way to go. So here, I'm going to create a set of R values. R equals R0, linspace of R0 up to R max, and I'm going to go 101 values to start with. And then it says back, I want to show you something else. So I'm going to go Control. I think I want to save this file. Save as pvt.m. It actually does look like a nice name for it. That's what it's suggesting there, pvt.m. So I'm going to save it as that, because pvt is what I call the function, and my file name is supposed to be the same as the function, but with a .m on it. Alright, so the other thing I want to do, just using the command window to play with, if I want to look up here how I made A kind of the long way. If I want to make an array that starts out with whatever A has and then continues on with what B has, I can do that. I'm going to change B. B, oh, by the way, I use the up arrow so I don't have to type so much. I'll go 40 to, let's say, 70. I want 40, 50, 60, 70, so I want 4 of those. I think. Yeah, because I'm including the first one. So 40, 50, 60, 70, that's 4. Let's try that. Okay, now this is what I wanted to show you. C, I'm going to make that, it's got first whatever A has in it, and then, but it's got however many elements A has plus however many elements B has, which is going to be 8 altogether. These come in first, and then followed by these is just the way I would type in numbers, but instead of putting numbers in there, I put the 2 arrays. So A comma B. And there it is, 0 through 30, that was the A part, and then 40 through 70. So C has 8 elements, the number of elements of A plus the number of elements of B, and it's A in its order, and then followed by B in its order. So I think I want to use that idea here. That must be why I started talking about it. So I want this then to go, I want another array tacked onto that one that goes from R max plus 1 step. I'm going to go minus 1 step size, which will be R max minus R0 divided by n. So the step size, I guess I want to play with that. What is the step size? If I go from 1 to 3, I'll have 1, 2, 3 values, so n would be equal to 3. And the step size, like from 1 to 2 or from 2 to 3, would be 3 minus 1 divided by 2. So I think I got to go divide by n minus 1. So linspace, and then down to R0, and I'm starting just like 1 step below the maximum value rather than right at the top, so I'm just going to use 100 steps. And then I think that's close parentheses, that's the end of my linspace, and then I want to put a square bracket there and a square bracket there. So remember what I just did in putting A and B together. I've done that. Here's 1. This is playing the role of A. It's an array that goes with 101 elements, and then this is playing the role of B in what I just did. And I want to tell you a little bit more about this, where I started. So let's actually try that. I'll be able to test it too. Besides maybe showing you, I'm going to do a Control S, go back over here to the command window. I'll go n equals, I'm going to go 4. And R0 equals 1, and R max equals 4, and then try, that's not what I wanted, Control V, that command that I had in there. R0 is defined, R max is defined. I want n in here, n plus 1. I was thinking of n being equal to 100. So I'd create an array that's got 201 elements, but R0, R max, and I think everything's defined there, so I'm going to try hitting return. And I want to go back over to here to fix that. Where I put 100 in, I wanted to keep it as an n. And this is n plus 1. So now what I just pasted is the same thing here. Now I was pasting it to see, to try to get an idea. So I got from 1 to 4. I'm thinking the numbers 1, 2, 3, and 4. I said 4 elements. N was equal to 4. Went from 1 to 4. For some reason I've put 5 in there. And let's try that with 3. So I'm going to go n equals 3, and then try this again. I wanted to go up to 4, 1 through 4, but I forgot I was using n plus 1, not just n. So if I said n is equal to 3, n plus 1 is 4, I go 1, 2, 3, 4. this is the first linspace, n plus 1. Since I set n equal to 3, this is 4. I'm going to get 4 elements from R0 I said was 1, and R max is 4. 4 elements from 1 to 4. 1, 2, 3, 4. And then I said I'll get 3 elements counting down from the maximum value, which is 4, minus, I should have left that as n. Oops, let's type that in again, and I want that to be n, because I want that to be 3, not 2. So n. And I think it's doing what I want it to do. I better fix it up where I'm actually using it. So just by n, not by n minus 1. Alright, Control S to save it, and then go back to my playground. So this linspace with n is equal to 3, this goes from 1 to 4. 1 up to 4 there, because I set R0 equal to 1 and R max equal to 4. And then it starts, got up to the maximum value that I wanted to go, right? R max right there, and then it starts counting down all the way back to 1. And I wanted to start with 3 was my point, rather than starting with 4, because then I'd have 4 duplicated. And so I had to subtract off whatever the spacing in between them was, which was supposed to be 1. So in my case, this would be R max, which is 4, divided by 4 minus 1, that's 3, divided by 3, which is 1. Minus 1. So my spacing is 1. If I were to go with 6, I think n equals 6. So I get n plus 1 here. So let's go with 5. Is that right? Let's try 6. I guess I want to be able to predict what happens. So if I go 6, R max, I'm going to get 6 values from 1 up to 4. So I'm thinking 1, 1.5, 2, 2.5, 3, 3.5, 4. That's 6 values, and then I'll get. So I need that to be 5 to go up to there. Let's try that. And I didn't quite have that right. I'll go trial and error. 6. And there it is, 6 exactly. So when n is equal to 6, I get 7 values leading up to 4. 1, 2, 3, 4, 5, 6, 7. There we go. And then an additional 6 values counting down. 1, 2, 3, 4, 5, 6. So this works no matter what I pick for n. N equals 100 would be a bit hard to see, but it's going to have the same idea no matter what I pick. Evenly spaced values, the spacing will always be the same, and then it counts up to the maximum value and then counts down from there back to the original value. So I've got my way of filling up R with the values I want it to have. Okay, now I want to calculate. Well, I guess I'll go back. I don't have to think about how to code it up. I already did the thinking over here. So I got step 2 done. Use equation 1 to get the corresponding array of v values with minus for values for the return trip. Oh. I think I'm going to get the speed values here. So I'll use this as an idea, but I'm not sure I'm going to do that exactly that way. I'm going to try getting all the speed values. What I'm thinking is the minus sign will come into the fact that when I step from one element to the next in the array, like it's not that one I want to look at, this one. When I go, well, I'm on the way up, it's positive, but when I'm on the way down, say going from 3.5 to 3, the step, the change in position is minus 0.5. So, oh, I get it. The amount of time that it's going to take. I do want a negative velocity, I'm pretty sure. Delta x divided by delta t. Have them both negative, and then the time increases. So, let's see how it works out. I'll just get the values first, and then might have to change things. I think what I'll do, I'll stick with the plan that I had, so I recognize that I'm changing. The one that I wrote down when I was developing the code outline. Find the velocity for at each position, and we'll see how that works out. So I'm going to divide R up into two different pieces. R1 is that one. I don't want to be able to address them separately. R2 is equal to that one. And R itself I can then write down. It's linspace of that. Something doesn't look right there. We'll see. Yeah, I think I just had a typo in there. That parentheses doesn't belong there. Alright. There we need a parentheses. So it's R max minus the step size divided by n. And I don't need any parentheses. We're good. So this is the one saying I'm inside. I need the arguments of the linspace. Here's my first argument, R max minus one step. There's the second argument. I'm counting from this high value down to this low value, and that's how many pieces I want. Okay. So that one is cool. I want to call that R2 though. R2 equals. I don't need any comma there, and I don't need the bracket at the end. So I think that looks good. And R itself is equal to R2 concatenated onto R1, like I did with the A and the B to find that C in my trials. And then V1, I'm going to use the formula. That set equation 1. So equation 1 is right here. Oh my goodness, what a monster. Alright, square root of V0 squared. Square root of V0 to the second power. That's not where I want to look. Plus 2kqq over m times 1 over r0 minus 1 over r. 2 times k times q times q sub f divided by m, and then times 1/r, I'll call it R1, minus 1/R0. And all that stuff goes inside the square root. Let's see, 1/R0 minus 1/R. So I'm going to put, no, I got it in the opposite direction. R0 first, and then R, but I'm doing it a piece at a time, so I'll call it R1. Now, R1 is an array, so, and I want to do this on an element by element basis, so I need a dot there. And then I'm taking the square root of an array. I think that'll automatically calculate the square root of the individual values, and I'll assign that to an array. So I got v0 squared, that was just a pure number, 25 squared, and then 2kqq. All of these divided by m, all just numbers, and then here's an array of values right here. The R0 is just the value as well. Alright, I think v2 equals minus, and then it'll be the same thing. I'm going to go Control V to paste it. I did a Control C to copy it. Prefer that these things line up, and I need R2 over here, the array of values where I'm counting down. I think I want to go ahead and try it. I believe I want to go, let's see what happens if I think I want to see some of these things, so let's print some of these things out. Control S, I want to try running it, PVT. I can put empty parentheses after it, but because it takes no arguments, it should be okay. Oh, PVT of 3. So, let's see what happens. I get 4 values going from the min up to the max, equally spaced. Looks like about, the spacing is roughly 10. And then counting down from there, I see these same numbers, but in the reverse order. That's cool. Then, my R values, when I put them all together, counts up, and then counts down, back down to 0.15. The V values, V1, I got started at 25, that's good. Jumped down to some really low speeds in a big hurry. I don't know if that's correct, but then, so this is, as the thing's going up, it starts with a high speed, gets slower, slower. This is presumably at the top. I would expect 0 at the top. And that represents a check on a number of things. So the top is 32.038. And I'm getting 0.00, which compared to 25.0 to 3 sig figs, I'm getting off of 0 in the 4th sig fig. I think it might be consistent with how accurate, how close to 0 it should be. But I'm not sure. I think I'm going to saved more sig figs than that in my calculations here. So for instance, it was the very first part. I think I want to open up another My Paint and open up a recent video 1. When I calculated the max height, I saved a lot of digits there, so I would expect it to come out 0. So this is the height. Y2 came out to be 32.038. The height at which I get 0 velocity. Let's check my work on that. So the height at which I have no kinetic energy. So the G is a positive 9.8. I've got 1/2 V1 squared. I get kinetic energy plus a little bit of potential energy because it's up there at 0.15 meters, and it's equal to, and in the after picture it's all potential energy because it's up high. So I calculate Y2 as dividing both sides by G. I'll have a Y1 and then V1 squared over 2G and 0.15. Alright, so then if I substitute that value into an expression for the final velocity, like V2 should be the other final velocity. Oh, you know what? I'm looking at the baseball on the one and the charged particle on the other. So I gotta go back to this one and say that's the baseball. Let's look at the charge. So here I got same thing with the charge. I'm setting the final kinetic energy is equal to 0. I'm more or less solving for something inside there, the velocity later on. But this looks reasonable. Subtract that from both sides. When I solve for V1. Oh, I see. I used that to get what the charge was. Minus 2.3098. So I think I want to make sure that I got the right charge. Minus 2.3098 times 10 to the minus 6. So I guess my point is I'm surprised that that's not coming out a little bit closer to 0. And because I am actually using that final value. So I think I'll go ahead and move on and see if I got a mistake somewhere at a later date. So for right now, I'm going to use that for the velocity. It's the velocity at the very top. I would expect that to be 0. It's coming out pretty close to 0, but I would expect it to be a smaller difference from 0 than that. Maybe I guess it's 0 to 3 sig figs and varying in the fourth, and I was carrying around 5, so I would expect it to be another 0 there and then something in this digit. So I might have to fix that up a little bit. If so, I probably have to go back and change pencil and paper. But for now, let's say, yeah, that's pretty close to 0. Plus, I'll take a look at it. Again, it is a small fraction of the total. So I'm going to go then v, the whole vector v is equal to v1 comma v2. And then let's see what I was supposed to do after that. Try to put those back together. And look over here. Get return values and make sure I put a minus sign on those. Yeah, minus. Alright. And then the time for one is 0. And then for the rest of them, this is v average. Alright, vi minus 1 and vi. So this goes for I is equal to 2, so the first one here and the second one there, up to the number of values. And I got 2n plus 1 values. So I'm going to try to get v average. I want to get an array of v average values. And I'm going to have one fewer than I got values in the other arrays. So I got 2n plus 1 in those. I'm going to have 2n. I mean, let's see. I want to play around a little bit. So I think I'm up to, I got A, and I got B, and let's say I wanted to stick, I think I'll go with C. C goes from there to there. And what I want to do is take, I want to add like this element to that one and divide by 2. And then this one to that one, divide by 2, and this one to that one, and divide by 2. So I want to show you something. What I'll be doing is I'll be adding all these numbers, that set of numbers, to all these numbers. So I'm going to break that up into 2 arrays. I'll call it C1 is equal to C of the first element, that's this one, up until the 7th element, the 60. 1, 2, 3, 4, 5, 6, 7. Up to the 7th element. And look at that, it creates an array that's just got one fewer element. And then C2 is equal to C of the second element up through the 8th element. So that is supposed to become these guys, and let's see if it does. Yeah. And then I'll go D equals C1 plus C2. I'll say divided by 2. So that has to do with calculating my average velocity for the time interval. So I get 5, 15, 25, etc. So if these original values were velocities, then I'd say the average velocity from here to here is roughly 10 plus 0, which is 5. And then the average value from here to here is roughly 20 plus 10 divided by 2, which is 15. And then here, 50 by 2 is 25, so it should go 5, 15, 25. So these represent average velocities. But you notice where I had 8 values of velocity, I mean 10 through 70 is 7 of them, and then one more, that's 8. I've only got like a value for going from here to here, from here to here, here to here. I got one fewer spaces than I have values, so I should only have 1, 2, 3, 4, 5, 6, 7 values there. The last one being 130 divided by 2, the average between those two, which would be 65. And that's what I got. 1, 2, 3, 4, 5, 6, 7. From 0 to 70, it was 8 values before, and now I got 7 values of the average. So it's this and this. Let's see what we got. Let's see if I can put those ideas into my code. So the average value, V average, I'm going to have a whole set of values, is first one, I guess I want to see that. Yeah, plus 1 after it, and then divided by, this would be like the very first one. When I is equal to 2, this would be V1 plus V2 divided by 2. I think I got it. So the first array starts at the start and ends one before the end, and the second one starts at one after the start and ends at the end. So V, but just elements 1 through 2 times n. Remember, it's got 2n plus 1 elements, n plus 1 for the first one, and then n for the second one, 2n. You know, that was concatenated onto it, or added to it. Concatenated onto it is the way to say it. Plus V, start with the second one, to going all the way up to 2 times n plus 1, and then that divided by 2. Need that over there. I don't know why we got a big black space there. I think I must hit the insert key by accident. Alright. So that's average values of velocity. I think I got them. And I've only got 2n of them, rather than 2n plus 1, which is how many values of velocity I've got. This is the average between each pair of those, or the average values. Alright, I wanted to look over here and see what I'm supposed to do next. So dt is the diffs. I want to create this as a diff of y. I think will work. I'm going to try typing it in there first. That was diff of r. So I should have called that r when I wrote that up. I think I want to do that. I'll fix that. So where were we? Yeah, mixing up R and I. Now work on the baseball. So let's go back and fix that up. So these should be R's over here. There you go. With white and try to turn those into R's. Where do they go? Video 1. I'm working on video 2. I'm going to try closing that one out. So these are all R's rather than Y's. So I'm just going to call that R sub I minus 1 V average. This R sub I, maybe I should put it R sub I minus 1. This is R sub I minus R sub I minus 1, I minus 1. Instead of that, all divided by V average. This is R sub I minus R sub I minus 1 divided by V average. And let's see if I did any more. Okay, now I'm working on the baseball and I do want to call it Y. Alright, so I had to fix up the pencil and paper part a little bit, but let's see what we got as far as. Alright, I'm going to go. I'm going to try DTs, the time intervals. It's going to be diff of R divided by, I go dot slash V average. So element by element basis, take what I get for this array of V average values and element by element divided into diff of R. So I want to show you what diff of R is. Control S to save that. Alright, over here it's Ri minus Ri minus 1 for each one divided by what the V average is. So I'm going to, I got an array of V average values. I want to create an array of Ri minus 1. And I'll go to the playground here, the command level, and let's go with, see what C is. Alright. The differences here are all the same, so let's go with, I'll call it E equals, I want differences to be more obvious. I'll go 1, 2, 4, 8, 16. And I got 1, 2, 3, 4, 5 values. Now the difference between these two is 1, difference between these two is 2, then 4, and then 8, but I'm only going to have 4 differences, even though I got because I started with 5 values. So there are the numbers, and I want to see if I remember this right for one thing, and also show you. So these are the differences between adjacent numbers. So this first one is the difference between these two. 2 minus 1, that's good. The second one is supposed to be the difference between these two. 4 minus 2 is 2. The third one, that's this one, is supposed to be the difference between these two, which is 8 minus 4 is 4. And then the last one is 16 minus 8, which is 8. So the diff thing seems to be working. If, by the way, with that, remember, A was that, I'm going to go with C. Oops, C is that. If we go to the diffs on that, they should all be 10. So diff of C, So further check on diff. They're all 10, and I should have one fewer value of them than what I had up there. I had 8 up there. I got 1, 2, 3, 4, 5, 6, 7. So that's perfect. So the diff thing seems to be working, doing just what I thought it was supposed to do. So this is like the distance that it traveled from the first instant to the next instant, divided by the average value during the time period from the first instant to the second instant, and that should be the time value. The change in time is the change in position divided by the velocity. If I multiply both sides by velocity, divide both sides by time, I got the velocity is equal to, or the average velocity during that time interval is equal to the change in position divided by the change in time. So that gives me the dt values. Then the time values, check this out. I want to give attributions because I'm going to show you where I got it, but or how I got it. So I'll put the attribution. I already looked something up, and I want the first time value to be 0. So the time values are going to be equal to 0, and then the next one should be the first time dt, and then the next one should be the first dt plus the second dt, etc. And it's referred to as a cumulative sum. I'm going to use it and then show you what it does. Cum sum of the dt's. And so the first element is 0, and then the rest of them are the cum sum of the dt's. And now t has as many elements as r does, because it had one less. From all these, dt had one less, and so this cum sum will have one less. But then I got the 0 there for the original time, for time 0. So let me save that and then show you what the idea of this cum sum is. First off, I'll tell you where I got it from. It was, I thought of it as being kind of like integration, so numerical integration, doing all this sums. So I did a Google search for integrate by just typing in MATLAB integrate. I might have typed in integration, but numerical integration, MATLAB, and gave me a way of finding the integral of a function. Integral of a function goes right there, and that's not really what I had in mind. So I looked down here to see also. I looked under trapezoidal because that's a numerical integration method in which you sum up a bunch of areas under. You approximate a curve by a set of straight lines, a whole sequence of straight lines, and then you find the area under each straight line. And that area is in the form of a trapezoid. That's why they call it the trapezoidal method of integration. So I looked under that, and then I was pretty sure that wasn't exactly what I wanted. And this is where I saw cum sum. This was pretty clearly going to be a cumulative sum. I was actually familiar with cum traps, so all I really needed was the name of it, cum sum A, for instance. And so I'm going to go as far as attribution. I actually have to do some attribution this time, so I want to get that in there. Since I looked something up, I might as well include it. Attribution, I think I'll go percent attribution is MathWorks pages Let's see, which one was this? Integral. Percent. Percent and percent. And I go from there. Trapezoidal. And that's the one that gave me what I wanted. Cube sum was C also. The cube sum is what told me that that's what existed. That's actually as far as it went when I was actually using it. I guess I'll put the whole sequence, that last one. So that goes, we'll go Control V and percent. Probably should put a comma after it grammatically, but I think it's easier to read it without. And okay, come on. Cube sum. That page. Control C. Control V. To find out about cube sum. And then I want to tell you what the deal is. So here's the idea. See C up here? Cube sum of C will create an array. I'll go ahead. I'm not going to assign it to anything. I'll just print it out. It'll go, the first element will be 0. The second element will be 0 plus 10, which is 10. The third element will be that plus 20, which is 30. The fourth element will be that plus 30, which is 60. The next element will be that plus 40, which is 100, etc. So let's make sure that it works out the way I thought it would. C's gone away, so let's put C there. So the first one is 0, just as predicted. The next one is supposed to be the sum of these two, and it's 10. That's good. The next is supposed to be the sum of these three, which is 30, and that's good. The next one is supposed to be the sum of all these, which is 60, and that's good. And then another 40 is 100, another 50 is 150, another 60, 210, another 70, 280. So that's the cumulative sum, or the set of cumulative sums. And that's what we've created here. So I had a bunch of dt, time intervals, and to say what the current clock reading is. The first one is 0, the next one is the first value of dt, the next one after that is the add on to whatever you had before the next value of dt, and then the next one add on to whatever you had before the next value of dt, etc. So that should actually be my set of t values. Okay, I think this, from here it should go pretty fast. Let's say, I guess, here we get positions and times for the charged particle, and then below. Now, let's go first. First, we get now we get positions n times for the baseball. I think for the baseball, I call them y values. I can just use whatever we had for r. I think. Let's at least try that. Oh, for the position variables. No, I was doing it a completely different way. So I'm going to go, let's see what I got for that baseball on here. Let's see if I can just follow directions. Use equation 2 to get t end. So t end. Where's equation 1? Well, there's equation 1. Equation 2 is that. So let's go ahead and do that. T end is equal to that. I could just plug in a value, but I've got V0. I just got a V0. V0y is, I'm calling V0, and AY is, I'm going to call that minus 9.8 meters per second squared. So T end. Let's try that. Alrighty. T end equals, whatever, I'll go G equals 9.80 meters per second squared. So now I forget what I had written down there, and it's minus 2 V0 over minus G. AY is minus G. So that's 2 V0 over G. 2 times V0 divided by G. Minus, or AY was minus G, so the two minus signs cancel each other out. Okay, now what am I supposed to do? Create an array of time values from 0 to t end. Let's make it 2n plus 1 time values, so make it just as smooth as what we had in the other case. So we'll go t ball. I use t itself for let's go with t particle. I think I'll just use t for the particle, so we know it's for the charge particle because we're working on the charge particle. Here, working on the ball. I'm going to call it t ball though because I gotta have them both. T ball equals linspace from 0 up to t end, and I want 2 times n plus 1 of them. Alright, then I use a formula presumably to calculate for each t, calculate y using equation 3. So let's try typing that in there. Constant acceleration equation. Y equals, yeah, I don't want that y is equal to r, I'm calculating y. Y equals y0 plus v0, y is v0 times t plus 1/2, I'll call it 0.5, times a sub y, which is a minus g, times t squared. Alright, so it's a lot quicker and easier to get the y values for the ball. And then what do we got next? What do we have to do next? Plot R versus T and Y versus T on the same graph. So I'm going to try plot. I'm going to try, what do we have? The T versus R, and then T ball, comma Y. It's actually R versus T, and that's the order you put it in to make a graph of R versus T, and then a graph of Y versus T ball. So let's see. I did an awful lot of typing there without any debugging, or without really checking things over carefully. So we should expect to have some errors in there. But I think I want to go ahead and try running it. Control S, and then let's PVT. I'm going to try n is equal to 100. And PVT line 25. So I'm trying to square T. I want to do it on an element by element basis. That means I need a dot to the power of symbol. That doesn't look too bad. That was near the end there. Put a dot there. So the up arrow means to the power of, and if I go T to the power of 2, when T is an array of values, a bunch of values. By the way, I should be using T-ball there. That was convenient. It's a bunch of values, and I want to do it on an element by element basis, so instead of just using the to the power of symbol, I got to use a dot to the power of symbol, so that becomes the to the power of symbol on an element by element basis. So here I'm just multiplying that array by a value, so I think that's all we got at that point. Boy, it went pretty far before it got an error there too. Let me look at what I just did there. I hit the up arrow thinking I was over here. Up arrow, run it. Oh, look at that. I got a graph. And this is looking pretty good. I don't know which one's which. But let's see, do I remember when that went all the way out? No, as far as the times, the force gets weaker and weaker with a charged particle, so I would think this one is it, and it always stays the same strength, but I'm not sure. I'm really not sure. This does look more like a parabola. This one almost looks like part of a circle, which I guess could also be a parabola. Yeah, at the end, I would think the force gets very, very weak. So I think the blue one's got to be the charged particle, but we can put a legend on there. And I had to look it up. Oh, I know how I looked it up. Help legend. And I misspelled it there. So I'm going to put that in my attribution. Edit. Used help legend to find out how to put legend on graph. Alrighty, And what I learned, well, I'll do a Control S there, and then let's see if we can see it here. I think because I got so little room for you to be able to view here, we might not be able to make sense of it. But it looks like maybe. So, legend, adds a legend in the specified location. Let's see. So, legend, string 1. A string is like a set of characters, and you usually put them in quotes. So I'm going to go item 1 in quotes, the first thing, and then item 2 in quotes. And I've only got 2 things that I want to put on there. And then where was that business about where to put it? Location in quotes, and then where you want it. Where I think, yeah, it's one of these. I'm going to try inside bottom. It looks like we got room in the inside bottom, so I'm going to go south. So let's try legend. So after I create the plot, I put a legend on it. I type in legend, and then I want I might change this a little bit, but this is for the charged particle. Charged particle, and then the second one was the baseball. And then I want to put location, and then south. And legend, I'll put a semicolon after it so nothing gets printed out, although I don't think anything would anyway. But I want to go over here. South had to be capitalized, and location is capitalized, so I think it actually looks good. I'll go Control S to save it, and then try going over and running it again. So, alright. Yeah, the charged particle was indeed the blue one. So things are looking pretty good. They both got the same distance away. I fixed that with the charged particle, and I didn't with the other one. It does, to me it looks reasonable. So that business about it having 0 velocity at the top, apparently it was close enough to 0, even though it seemed like I would have had one more significant digit in there. It would have been a little closer to 0, but it was pretty close to 0. So the force gets weaker and weaker, and so it's kind of drifting out there in space for a while, and it comes back. So it takes a lot less time for the baseball to get back to Earth than it does for the charged particle to get back to its starting position. And this green graph is parabolic. I think even if we were to stretch it out, to me this doesn't really look parabolic. It looks closer to being part of a circle, and I want to play around with it just a little bit real quick. So I'm going to go I'm going to copy this plot command, Control C, Control V. I don't want to lose it the way it is, so I'll put % there, and what I want to do is plot just the ball. So try to remember what that graph looked like, and then I go put a % on there so I don't put any legend on it. So if I just plot the ball, I want to spread it out. My problem is I can't really see it all that well, but take a look at this blue curve. That's the way the trajectory, or the position versus time graph, looks like for the charged particle. And then if I spread out the plot, Control S, run it. This is what looks like for the baseball. I don't know if I had the graph in the right spot for you guys to be able to see it. But to me, this looks significantly different shape-wise. So even if I spread it out so it's pretty much the same size as the other one, in here, the other one had steeper sides. It was more like part of a circle, whereas what I got there looks like a mountaintop or part of a parabola. So that's interesting too. So the shape is different for the case of the charged particle moving in a non-uniform field than for the case of the baseball moving in a uniform gravitational field. So I want to try to get it back to where it was. So I think things are looking good. That business that I was worried about with the zero, to me it looks good. We would have had something strange happening up there if it weren't for that. Then I went the legend, so I know which one's which. So the first string is for the first thing that was plotted. The first thing that was plotted was R versus T. That was the charged particle, so I got the right string there. Second thing that was plotted was the baseball, so I got the baseball as the second thing. And then this just tells you where to put the legend. It tells the computer where to put the legend. And then I want to run it one more time, make sure I'm back to where I was. Okay, I'd say we got a lot of documentation and finishing touches to do, but it looks like I got this baby working, and I get to find out, what the two trajectories were like. Like I know what the but the two position versus time graphs look like. I know what the position versus time graph would look like for a baseball. We are neglecting air resistance there, but I didn't know what it would look like actually for a charged particle. And to me, it looks ever so close to a circle. Isn't that cool? Alright, that does it for Project 2 video number 3.